Good evening, sir.
Yeah, good evening, everyone. Good evening, Harshit. So, how many of you are trying and were not able to connect to the class?
Sir, actually, I think you didn't start the class before. You kept the message, but we were not able to see the join button.
Okay, actually, what had happened by mistake, I had started the class 10th session. Okay, so maybe that was the error. So then suddenly I realized and then I started your class. Okay, so anyways, I think all of you are there. Now today we'll be starting with separation of substances. We'll see how to separate out different substances or from their mixtures. Okay, so separation of substances from their mixtures. Let's see. So depending on the properties of the substance, see what are the properties that we are looking for. We are looking for the properties of solubility. We are looking for the properties of uh, boiling points, melting points. So the physical properties which can look for the substances, we are looking for the physical for their physical properties, and depending on those physical properties, we will be able to tell how to separate out the different substances, depending on the size of the depending on size of the particles, depending on whether the substance can undergo sublimation or not. So these are all physical properties. So depending on the physical, also the density, in some of the cases, we'll also take the help of the density of the substances. So where you will find if the density of the two substances is different, you can separate them easily. So all the substances, they will differ in some of their physical, some or the other physical property. So depending on those properties, we'll be able to separate them out. Right? So for example, we'll also see depending on the size of the substances. So what size the soluble particles are. So depending on that, we'll be able to separate the different components. So here, we'll start with what are the substances which can be separated by the process of filtration. Okay, the simplest process that we perform is the process of filtration. Okay, so to obtain a filter paper, and let's see how do we create a filter out of it. A filter paper is supposed to have very tiny holes. So filter paper is used to separate the contents of the substances. So see how can they be used to separate the contents of the substances. In case of filter paper, see, so first method of separation we are going to study with filtration. So as you know, the filtration can be used if the solvent is liquid. Solvent is liquid and solute is solid of particles of size few mm. So, so if the particles are of size few mm, then we can use the process of filtration. We can also use somewhere the process of sieving, which is similar to that only. When we use to separate two solids of different sizes, so then we use the process called sieving. So sieving can be used, for example, as you know, we sieve the wheat flour to obtain to separate out the contents from it, to separate the contents wheat and the rusk from it. Okay. So here, in the process of filtration, we can separate out. Suppose we have a mixture of. So suppose we have a mixture of soil and water, or if you have a mixture of chalk powder and water. Okay. So these two mixtures, mixture of chalk powder and water or mixture of soil and water, they can be separated out by the process of filtration. Okay. So how do we use a filter paper? Initially, we take a filter paper and we fold it
So,
in. Yes.
sir, the particle size is 1 millimeter.
Yeah, it has to be around the size of few mm. Okay.
Okay, sir.
Then only they can be separated out. 1 mm, 2 mm, 3 mm. If this is the particle size, then they can be separated out easily by the
So
process of
can
filter.
it be like 0.2 mm like that much?
No, if you are having a particle of size 0.2 mm, that cannot be separated out. 0.2 mm, yeah, 0.2 mm can be separated. If you have 0.02, that cannot be separated. Okay.
Okay,
So
sir.
0.2 mm can also be separated. It's about 1/10 of a millimeter that can be separated. Got it? So these can be separated out. If you take a filter paper, the filter paper has very tiny pores. So the particles which are bigger than the size of the filter paper, they will get separated out with the use of the filter paper. Okay. Then there is still another method for separating out these substances where you have an insoluble substance. Here, if the solute is insoluble, if you have insoluble solute, so this process can be used. Either you can use filter paper or there is still another method that can be used. You can use sedimentation and decantation. Sedimentation and decantation. Sedimentation is the process where we allow the sediments, where the sediments are allowed to settle down, or the solute particles, they are left for some time so as to allow the particles to settle down. When the solute particles settle down at the bottom, so it can be separated out by the process of decantation. Decantation means pouring the contents of the substance from one to the other, from one beaker to another, from one container to another container. That process we call as sedimentation and decantation. Got it?
Yes, sir.
Okay. Just wait. So this is the process. The other processes which we use is, for example, you might have seen this process of evaporation or boiling. Evaporation or boiling. So here, the if the solute can be boiled, or if the solute can be boiled easily, where or solvent can be boiled so that the solute can be separated. For example, for this, if you have a mixture of sugar and water. So in the mixture of sugar and water, sugar is soluble in water, and hence the particles of sugar cannot be separated out by the process of filtration. Got it? So the particles, they cannot be separated out by the process of filtration. So the process here is evaporation or boiling. You can boil the contents. So all the water molecules, they get boiled up, and only the sugar particles will be left behind. Since sugar particles, they have a high boiling point, so they will be left behind. Okay. So this process
Can
is
you
called as,
take salt and water?
yes, you can also use for salt and water, where salt is soluble in water. So you can use this process for salt and water also. Okay. So understood these two processes of filtration,
Yes, sir.
sedimentation and decantation, evaporation and boiling. Okay, okay, there is still one more process which we call as sublimation. So can anyone tell what is sublimation process? Yeah, what is the process of sublimation?
Sir, when solid directly gets converted into gaseous state on heating and
Yes, so sublimation is the process when solid, it converts directly into the gaseous state without going into the liquid state. So solid does not go to the liquid state, it directly gets converted to the gaseous state. Okay. So this process is called as sublimation. Can you give me some substances which can sublime?
So dry ice,
Sir,
Okay.
naphthalene balls.
naphthalene
Sir,
balls,
camphor.
Okay. You have these substances, naphthalene balls, which sublime. You have dry ice, camphor. So these are the substances which can sublime. That means they directly change from their solid state to the gaseous state without going into the liquid state. So this process we call as sublimation. So different substances can be separated out by the process of sublimation also. Okay. For example, a mixture of ammonium chloride and salt can be separated out by the process of sublimation. Okay. We'll see these examples. Just wait for 1 minute. I'm showing you the notes. Sure. Just wait for 1 minute. Okay, so here each one by one we are looking at the processes. So as we saw that the sublimation is the process when the substance undergoes directly change from solid state to the liquid state. So here it is used for the substances that undergo sublimation, where the transition where they transition directly from solid to vapor state without passing through the liquid state. For example, separating ammonium chloride and common salt. So the formula of ammonium chloride is NH4Cl and formula of common salt. So out of the two substances, so see here we take a beaker and in that beaker we put up, so in the beaker we put up here both the substances. So for this process, we generally take up a conical flask. The reason why we take a conical flask, I will tell you. So here we are taking a conical flask and in this we add the mixture of ammonium chloride and sodium chloride. So both the mixtures they are added up here and when you start heating it, so when heat is supplied, ammonium chloride which is NH4Cl, this is ammonium chloride. So your ammonium chloride, it converts directly from solid state to the gaseous state. So ammonium chloride, it starts to come out of this conical flask. It tries to come out. So that this ammonium chloride does not escape, we apply a cotton plug here. We fill this conical flask with cotton plug so that whatever ammonium chloride evaporates out, it should not go out of this conical flask. Okay. Since the bottom part of this is heated, it's hot, and the top part is cool. So when ammonium chloride comes in contact with the neck of the beaker, so the neck of the beaker is being cooler, the particles of the ammonium chloride, they stick to the surface of this conical flask. They stick over here and they do not move out of the surface. Also, they cannot remain on the surface as the surface is heat. Here it's hot. So all the particles of ammonium chloride, they move up and they stick to the surface of this uh, conical flask. So this is your ammonium chloride. The flask which we have taken is the conical flask. As the At the top, we have taken here cotton plug. This is a cotton plug. Got it?
Sir, is there any other example of this?
Yeah, you can take, suppose if you have an example of camphor and salt.
Sir, can we take iodine? Okay.
Iodine. No, we can't take iodine, as iodine will easily change into the gaseous state and it's already in the liquid state.
Sir, we
So
will
we
get
can't.
iodine in can we get iodine in solid state? Actually, I saw a video in which iodine was in small balls.
Okay. See, obtaining the substance, there are three substances which control the state of a substance. The three factors which control the state of a substance, they are pressure, volume, and temperature. Okay. So these three substances, they control whether a substance will be in the solid state or liquid state or gaseous state. For example, I can have ice at even a temperature greater than 0 degrees Celsius. If I vary the pressure, the fact we have studied that a melting point or freezing point of water is 0 degrees Celsius. This fact is applicable for the atmospheric pressure only. That means when there is atmospheric pressure, so at that pressure, water freezes into ice at 0 degrees centigrade. If you change the pressure, okay, if you change the pressure, so the state will change.
Sir, if we increase the pressure, in which state will it become?
If you increase the pressure, then it will be in the liquid state. If you decrease the pressure, it will be in the solid state. Okay. What you have studied that iodine to be in the form of liquid state, it may be in some compound form. Okay. Otherwise, you can't have iodine at room temperature in the form of solid.
Okay, sir.
Okay. So you can take an example of camphor and salt, where camphor is a substance which can easily get converted from solid state to the gaseous state. Okay. So this process is applicable only for those substances or those mixture where one of them can sublime.
So, what is the boiling point, means melting point of salt?
Melting point of salt.
Sir, is it there or not? Means,
You can Google it out and find out the melting point of salt. I think
okay,
it has to be something about near about 2000. You can check it out. I'm not aware of approximate which I'm telling you.
okay, sir.
Okay. So have you found out what is the melting point?
Sir, just 1 minute.
Okay, these are the facts. Okay. Filtration we have already done. Next process is centrifugation. So centrifugation process, it is utilized to separate suspended particles from a liquid by spinning the mixture at high speeds in a centrifuge. See why we call it as centrifuge? It depends on the density of the substances. Okay. So
Sir, the melting point of salt is like 801 degrees Celsius.
okay, 801 degrees Celsius. Okay. So now you can remember this fact that melting point of common salt is 801 degrees centigrade. Got it? So these are facts. There are different facts which you can keep in your mind. Generally, we do not keep the facts. So if you want, you can remember them. All right. So shall we move ahead?
Yes, sir.
Okay. Okay. Thank you for sharing your information. Now this one, centrifugation. See, in the process of centrifugation, if we move anything, if we try to centrifuge a substance, centrifuge means if we move a substance in a circular path, so that substance experiences an outward force. Okay, for example, if you are just imagine if you are sitting in your car and car takes a circular turn. So what happens to your body? Doesn't your body feel an outward force? Yes. If you are sitting in a car and the car takes a circular turn, so if it's moving in a circle, so does your body feel an outward force?
Yes, sir.
Yes. So the bodies feel an outward force. This outward force is called as centrifugal force. Since it is away from the center, so we call this as the centrifugal force. Okay. So all the substances which will move in a circle, they will experience a centrifugal force. Now this process is used, or this method or this principle is used in the separation of substances by revolving them at high speeds. So if we revolve the substances at very high speeds, they are about to experience centrifugal forces. They will experience centrifugal forces. And the centrifugal force, it depends on the mass of the substances. So the lighter particles, they will get away from the center, and the heavier particles, they will try to remain at the center. Okay. So the heavier particles, they try to remain towards the center, and lighter particles, they try to move away. So because of this centrifugal force, those lighter substances, they move away from the center. Got it? So to attain this, the substance is rotated at high speed. Now, where all do we use it? Where all do we use it? What about the working of a washing machine?
So the
How are
clothes
the
experience an
yes?
outward push.
Yes?
The clothes inside the washing machine experience an outward push.
Yes, not the clothes. See, when clothes are put
Sir,
up
the
in the
water
machine,
and detergent particles will explain, no, sir.
see what happens. Your fabric is there, okay, and on your fabric you have dirt particles. So your fabric contains the dirt particles. And if you are using a detergent, so your detergent, okay, so these are the dirt particles. Now what happens with your detergent? Your detergent bonds itself or binds itself with the dirt particle. So detergents, they bind themselves to the dirt particles. Got it? So when the detergents are bound with the dirt particles, so what happens? Now, the dirt particles, they feel to be a little bit attracted away from them. Now, when the washing machine is rotated, when the washing machine starts rotating or when it starts working, so as you have seen in the working of the washing machine, the machine centrifuges it. It starts rotating at high speeds. So when it rotates at high speeds, so the dirt particles, they experience a force towards the center, whereas the clothes, they experience a force away from the center. Okay, so the fabric itself, it wants to go away, whereas the dirt particle along with the water and detergent, it wants to remain in the center. Okay, so more force is experienced by the fabric as compared with the dirt particles. So dirt particles, you can see that there will be a force between them. It's like that water is trying to pull the dirt particles away from the fabric. And in this process, the dirt particles, they are separated from the fabric. Got it? So this process of centrifugation is used in the cleaning of clothes. It's not that your machine is rubbing the clothes. It doesn't rub the clothes. Got it? Any other doubt to anyone?
No doubt, sir.
Okay.
So actually, will the dust particles move with the water pressure which we keep connect to the washing machine?
Yes, the dirt particles they will move with water.
Okay, sir.
Okay. Now another thing which we observe for the centrifugation, churning of milk. Okay. So during the
Sir,
process
here
of
the fat particles of the milk will get separated, no, sir.
yes, so here as we know, in milk contains fat particles, it contains proteins, right? Milk contains fat particles, it contains proteins, it contain certain other substances. Okay. Now it contains sucrose and other substances also. So when churning of milk takes place, when milk is churned, so out of them, fats have the lowest density. The density of fats is low. So fats have low density, proteins and other substances, they have higher density. So when in the churning of process of milk, so again the centrifugation works here. Because of the centrifugation, again the fat particles, they experience lesser centrifugal force. So they try to remain towards the center. Whereas the heavy particles, they experience greater force and they move away. Got it?
Sir, in restaurants, they'll use salad spinners, no, sir. There also this centrifugation gets applied.
Yeah, what happened?
Sir, in hotels and restaurants, they use salad spinners to remove water, no, sir. There also centrifugation applies.
Yes. Okay. So I think we everyone has understood the process of centrifugation. Is there anyone who has seen somewhere else the process of centrifugation being used?
Sir, can you write about centrifugation? Means like for notes.
Okay, you want the definition of centrifugation in words. So see, it is utilized to separate suspended particles from a liquid by spinning the mixture at high speeds in centrifuge. Denser particles settle at the bottom, forming a pellet while the liquid remains above. So by this process, you are able to separate the substance. You can add this up.
Sir, what is the meaning of pellet?
Okay, pellet means some solid substances which are insoluble in a liquid.
Okay, sir.
Okay. So for example, when you are bathing, so just after bathing, you can observe some solid particles in your bathroom which are along with the soap. They are also
Yes.
called pellets or scum. Any other thing?
No, sir.
Okay. So the process of centrifugation we have done. It is utilized to separate suspended particles from a liquid by spinning the mixture at high speeds. So this method can be used. Can anyone tell me when this method will be used?
So centrifugation.
Sir, when the particles of two particles have different masses.
Yes, when the particles are of different masses or different densities. When the particles are having different densities, then we can use the process of centrifugation to separate the substance. Okay. So, okay, the next process is evaporation. So, already discussed about evaporation. It involves heating a liquid mixture to evaporate the solvent. So whatever solvent is there, that solvent is evaporated out so that the other substance remains over there in the solution. For example, we have done the mixture of common salt with water, or the mixture of sugar with water can be separated out by the process of evaporation. Now, see, I think everyone has understood about evaporation and learned about evaporation in previous classes also. So there is not much about the process of evaporation, and you know that which methods can be which substances can be separated out by the process of evaporation. Okay. Now this is a new process. Crystallization process is a new process. Okay. So anyone who has heard about the crystallization process?
Sir, I heard, sir.
Okay.
Sir, in
So
separation of sulfur dissolved in water, sulfur solution.
okay. See what happens while in the process of crystallization. Before we go to understand crystallization, we should understand what are crystals. Okay. So crystals are salts which contain some amount of water in them, and they are used to form specific bonds that provide some special shapes to the crystals. Okay, that gives some special shape to those substances. So during the process of crystallization, you have some before that, let me show you some crystals of copper sulfate. I will show you some crystals of mishri, which we call as sugar crystals. Okay, so you will see crystals of copper sulfate first. How many of you have seen those crystals of sugar which we call as mishri?
Sir, sir, we use it in deserts also.
Okay, see, the crystals of copper sulfate, they are blue in color. The color of the, see, these are the crystals of copper sulfate. They are blue in color. The shape of these crystals is about just like the diamond. See the shapes. So crystal is a substance which has a specific shape. And if you have a cluster of crystals, so it can be broken about, or it can be broken down, only about a specific axis. You cannot break it over from anywhere. You can break it from a specific axis only. Okay. So all these, they are the crystals of copper. Okay.
So the
In the same
crystals
way,
of copper sulfate are they means harmful
harmful in what sense? Harmful in touching, or harmful when you
to
eat it?
consume or anything like consuming or anything?
No, if you consume it, of course it's harmful. Okay. Can you consume common salt just like that?
No, sir.
No. So copper sulfate, this is a crystal. This is also a salt. Okay. But it has other properties. So it cannot be consumed. Copper sulfate cannot be consumed. And you can touch it by your hand. There will not be any problem if you touch it by hand. But as a general measure in a laboratory, you are advised not to touch things with your hand. So you can touch these crystals with your hand. Okay. I'll also show you the crystals of Mishri. See. Almost everyone has seen this. You must have eaten up this also. So see, this is the one which is formed during the process of crystallization. It has a thread in it. Like you can see any of these pics here also. It has a thread in it. The other ones which we see, the crystals being broken into these smaller pieces. Okay, these are also the crystals of mystery, but they are somewhat machine made. They are cut along the specific axis. The shape of all of them is the same. Can I say that shape of all of them is same?
No, sir.
No, sir, they have
No,
irregularities.
they are different in.
So
Shape.
in size, shape.
See, all the crystals, they are similar in their sizes. The shapes, they are similar in their shapes, but sizes may be different. This crystal which we see, it is a cluster of small crystals. Like the small mystery which you have, they are attached over here together to form a bigger crystal. Okay. So all these, they are the forms of crystals. Now, how do we form crystal? How the crystals can be formed? Okay. To form any crystals, first you have to make a super saturated solution of a substance. Okay. When I say super saturated, so
So we
before that,
can heat the
yes.
water and mix sugar more.
Okay. So what is a saturated solution here?
Sir, in which a solvent has the uh,
Sir, a solution in which no more solute can be dissolved at the room temperature.
Solution, yeah, a solution in which no more solute can be dissolved. So what is a super saturated solution?
sir, a solution in which a solute is dissolved more than the saturation
Yeah,
level.
more than its saturation. So how is it possible?
Sir,
So
increasing its temperature.
Yes,
we can
we make
increase temperature.
we can increase the
Temperature.
yes. As we know that when we increase the temperature of a solution, its solubility increases. Solubility of the salt increases by increasing the temperature. I'll show you the solubility of salt at different temperatures. So before we move, let us also see the solubility of common salt in water at different temperatures. So we will observe the solubility, it's different. So here, this table gives you the value of the sodium chloride or the amount of sodium chloride that dissolves at different temperatures. So if you increase the temperature of the substance, the amount of sodium chloride dissolved increases. Just just 1 minute. Let me get a proper value. Yeah. So this table, see, for the sodium chloride, the solubility at 283 Kelvin is 36. At 293, it's also 36. At 313, also 36. At 333 Kelvin, it becomes 37. 353 Kelvin, it again becomes 37. So for all these salts, we observe that their solubility increases on increase of temperature. Okay. So can we observe for all the salts that their solubility increases with the increase of temperature?
So can you repeat?
Can you observe here in the table that the solubility of all the substances is increasing with the increase of temperature?
Yes,
Yes,
sir.
sir.
Okay. For potassium nitrate, it was 21 at
Solubility is directly proportional to temperature.
yes, solubility is directly proportional to temperature as it increases the space between the particles. Okay. So it also increases the molecular motion, therefore the solubility increases. So here to if we want to find out or if we want to make crystals of a substance, so first of all we create a super saturated solution. We create a super saturated solution. So super saturated means we dissolve the okay, let us try to understand how we are able to make the super saturated solution. So here we take water and suppose the solubility of sugar We are generally discussing for sugar here. So if the solubility of sugar is, let's say, 10 gram per liter. Okay. So suppose the solubility is 10 gram per liter at 20 degrees centigrade. So this value may not be exact value, may not be the true value. We are just assuming it. Got it? So we have sugar dissolved in 10 gram of sugar in 1 liter of the solution can be dissolved at 20 degrees Celsius. So instead of adding 10 gram, we add here 20 gram of the solution, or let's say we add 10 gram only. So when we add 10 gram of the solution, so it is a saturated solution, and now we start boiling it. When we start boiling it, so water particles will get evaporated. So slowly and slowly, the amount of water content over here will decrease. When the amount of water content decreases, so suppose after some time the water content has become this much only, all the water has evaporated. So now do you think the solubility will still remain the same? Can I
Also,
say
it
that
will
the sol
increase.
okay, can I say that the solution has become super saturated?
Yes, sir.
Yes, now the solution has become super saturated as the substances have been, as the more and more amount of water has been removed from it, so now it has become super saturated. So what will happen if I cool down this? If I cool down this water, so what is
So the
expected?
crystals of sugar become separated from the water.
Yes, the crystals of sugar, they will separate out from the from this mixture. So from the mixture, the crystals of sugar, they will separate out. So whatever sugar particles are formed over there, sugar particles, they will start separating out, and they, as when the temperature decreases, they cannot remain in the solution because solubility has decreased. It is just like when you are decreasing the temperature, so it's just like you are decreasing the space. And when you decrease the space, the substances which are there, they will be removed out. Yeah, Advait, is there any doubt?
Sir, I didn't get what exactly is super saturated solution.
Super saturated means a solution which has more amount of salt dissolved than it can. At normal temperatures, whatever substance of whatever amount of salt it can dissolve. Okay, so for example, in this case, suppose you have 100 ml of water. Let's say for the sugar we are taking, 10 gram of sugar can be dissolved in 100 ml of water. Okay, it can be dissolved. So we have dissolved it, we have made a solution. Now we heat it. So after heating the water vapors, they start moving out of it. So when water moves out of it, after certain substance, let us say only 50 ml of water is left, and you still have 10 gram of sugar in it which is dissolved. So can I call this solution to be a supersaturated solution now? Can I say that it has its solubility? Now the solubility of salt is even greater than its normal value. Earlier
Yes,
it
sir.
was 10 gram in 100 ml, and now it's 10 gram in 50 ml.
Sir, like the
Yes.
solvent is decreasing.
Solubility is increasing. See, here the
No,
solubility,
solvent.
yeah, the solvent is decreasing. When the solvent decreases, so 50 ml of water should be dissolving only 5 gram of sugar. But at this stage, we have still 10 gram of sugar being dissolved in it. Okay. So
Yes,
that
sir.
is why we call this solution to be a super saturated solution.
Okay, sir.
So this is a super saturated solution. And now if you want to separate out these substances, so you can form crystal. You can, if you cool it down, so again its solubility will reduce. Okay. When the solubility reduces, so the copper sulfate particles or whatever substances are there, they will separate out from the solution. So they don't just separate out singly, they separate out all their molecules, and they form their bonds with water molecules also, and then separate out from the solution, taking some specific shapes. So some specific shapes of the solution, they are found, of the crystals, they are obtained. Got it? In the same process, it is the same process by which we obtain the crystals of mystery. Okay. To have the more crystals being formed, we use a thread over there. Okay, anyone having any doubt? See, in this chapter, I think most of the students, they generally feel doubt in either centrifugation or crystallization, as these are the topics which they have learned newly. So is there any one of you who is having doubt in centrifugation or any doubt in this
No
process of
doubt, sir.
No,
crystallization?
sir. No, sir.
No,
Okay, so that's nice that all of you have understood the process of centrifugation and crystallization.
Sir,
The next, yes.
sir, here in this process we have to also cool down it.
Yes, you have to cool it down. So when you cool it down, its temperature again becomes 20 degrees Celsius. So at 20 degrees Celsius, it won't be able to dissolve this 10 gram. Okay, it will be able to dissolve only a few lesser grams only. So the extra amount of copper sulfate or substance or sugar is, whichever is there, so it will try to move out of the substance. It will be forced out of the solution. So hence it forms crystals.
Okay, sir.
Okay, so the next one is here.
sir, time.
Time.
Actually, we have.
Okay, I think your class is up to 8 p.m., right?
No, sir, actually, it's up to 7:40.
Okay. No, what I was informed that class is from 7 to 8. Okay. So that is why we have classes only 3 days. The science classes are only for 3 days. It's because of 1 hour duration. Okay.
Okay, sir.
Okay. However, if you have any important work, if you need to leave, so just inform me and then you can. Got
No,
it?
sir, actually, I thought 40 minutes because all the classes are 40 minutes. Yesterday we
Yeah,
had none.
all classes are 40 minutes, but your science class is for 1 hour, which is from 7 p.m. to 8 p.m. Any one of you who is feeling like you have some work, you need to go somewhere, so inform and then leave the class. That looks like a good habit. Don't just leave the meeting and go away. Just assume a physical class and you are moving out of the class without informing. That's not good. Now the next process is chromatography process. So these are the processes. See, chromatography, distillation, fractional distillation. These three processes, they are the processes which are new to you. You don't know about them. Okay. Chromatography, it is a technique of finding out or separating the contents of a substance. Okay. It is very useful in at higher levels also. For example, whatever substances are dissolved in it, they can be separated out by the process of chromatography. Okay. It works on the principle of absorptions and desorptions, which generally include the molecular forces. Okay. So in chromatography, we will be generally dealing with the molecular forces which are involved. Got it? Okay. So in chromatography process, I'll just show you with a pic of the chromatography. How does chromatography look like? So chromatography of
Sir, chromatography is used for separating ink colors.
ink color components. Generally, the color components are separated out by using
Sir, it is a
chromatography
filter
technique.
paper, no?
Yeah.
Is it a filter paper? Like a type
No,
of
it's
filter?
no. It's not a filter paper. It is just chromatography paper. The paper specifically is called as a chromatography paper. So you can understand the chromatography paper by this process. See here, suppose I want to see what are the different substances which are contained in an ink. Suppose I want to see black ink, and I want to see what are the different substances of which the black ink consists. So I put the black ink over here as a dot. I use a carrier over here, like it may be water or it can be acetone, different substances can be there. So depending on absorption, the different color components will start moving on the solution. It will start moving on this solution upward, on this chromatography paper upward. So as you can see here on the sideways, we can see that a blue color component is there, which is at the top. Then you have a purple color component. Then you have an yellow colored component. So in this way, all the color components can be separated out from.
Sir, actually, where will we get this paper?
Yes, where?
Will we get a chromatographic paper?
Yeah, chromatography paper is only, or generally the laboratory, the people who are performing those laboratories, the people who supply the laboratory material, they can provide. Even in your school laboratory, you will be having chromatography paper.
Okay, sir.
Okay, so school laboratory will have chromatography paper you can use.
So, what is the chemical formula of sugar?
C12H22O11.
So, can you repeat?
Okay, it's here. Sugar is C12H22O11. You can assume this sugar to be made up of two glucose molecules. One glucose molecule is C6H12O6. So if you take two glucose molecules and remove a water molecule from it. So multiply this glucose formula by 2 and remove one water molecule from it. So see, you will get C12H24O12. And from this, if you subtract an H2O molecule, you will get your sugar. Okay. So your sugar is actually made up of two glucose molecules joined together. Understood?
Yes, sir.
Okay, Advait, any other doubt?
Sir, about the chromography paper, we have to take water also for that.
Yes, you need to take water in a beaker so that this is how it happens. The chromatography paper over here, it's like this. Here you have water. So the water is absorbed by this paper and water starts rising up. When water starts rising up, so along with water, the different components of the paper, they also start rising up. Okay, they get absorbed by this chromatography paper, and hence we can see the different color components. Got it? Any other doubts?
No, sir.
Sir,
Okay,
like
so by
instead of
yes,
black ink will rise up and we can see other colors.
see, black ink is made up of different other color components. Okay, so that is why in this process you get different other color components.
Yes, sir.
Okay, okay, so bye all of you. Happy learning.
Okay, sir.
Okay, bye.
Bye. Thank you, sir.
Sir,
Yes,
hello, sir.
yes.
Sir, my exam is on Monday, on 8th.
Okay,
Sir, we have only a little part of the chapter, but can you send me a few questions?
from which chapter?
Sir, motion is only till distance, till velocity time graph,
Okay,
and
okay, so
chemistry is only till states of matter, properties of states of matter.
okay, I'll try to send it to the group.
Yes, sir.
Okay,
Sir,
okay,
in
bye.
chemistry, in the first chapter of chemistry, matter and its particles and its surroundings.
Mm.
Sir, can I write the properties of matter in short if it's a 5-mark question? If it's asked for
No, no,
differentiation?
no, no, no. Try to skip the shortcuts.
Sir, I should
Okay.
write in proper terminology, right?
Yeah, write the proper terminology.
Okay, sir.
Okay, so bye.
Thank you, sir. Bye, sir.
So can you give
You
any
can,
extensions on motion and uh, this matter?
what, pardon?
Matter, matter and motion.
Okay, you want the question for matter and motion both.
Yeah, sir. Because I have exam on the next week.
Okay, just I will try it and send it to you.